Welcome back. In the second part of this section, we'll be talking about exponent properties and about rational exponents. First, just a recap of some exponent properties that you'll remember from previous math classes. So, dealing with things where we're multiplying things with the same base, or dividing things with the same base, or raising powers to powers. These are, again, properties you will have seen before. The one property that sometimes people will forget is, what does a negative exponent mean? Negative exponent meaning a reciprocal. So, for example, 2 to the power of negative 3, that would be the reciprocal of 2 cubed. Or if you had 4 to the power of negative 1, that would be 1 over 4 to the power of positive 1. Then a negative reciprocal is just, a negative power is just moving things from top to bottom or from bottom to top. So for example, 1 over 4 to the negative 3 would be the same thing as moving it to the top, 4 to the positive 3. We've got a couple of other properties here that are similar to the ones that we had for roots. We had something with roots where it was a root of a product is the individual factors in roots, and a similar one for the fraction. Root of a fraction being the root of the denominator and the root of the numerator. Again, same sort of property here for powers. That if you have a product raised to a power, that's the individual factors raised to that power. If you have a fraction raised to a power, that's the numerator and the denominator, both raised to that power. I didn't write in here little side notes about b can't be 0, and I figured that that could be taken for granted because, of course, for fractions you don't want the denominator to be 0. So here b can't be 0. I should also say here a can't be 0 because you wouldn't want a in the denominator if a were 0. Same thing with this one. A can't be 0 as well. But again, for these exponent properties, other than that case of where the denominator turns out to be 0, these properties would otherwise always hold. So even if the exponents were not positive numbers, even if they were negative, even if they were fractions, the exponent properties would still hold. So to simplify this, we've got some things that we'll need to do, and what I'll want to do now is use my exponent properties to make that happen. The first thing I would say is I've got x squared times x cubed, which I know that I can simplify that by adding together the exponents. That's x to the 2 plus 3, or x to the 5. We have y squared over y to the 4. That's y to the 2 minus 4. I'll deal with the cubed that's outside afterwards. For the 3x that's being squared, that's 3 that's being squared and x that's being squared. So it's really 9x squared. And for the last term, 2y to the negative 3, that's the same thing as y to the, 2y to the positive 3 in the denominator. All right, so just a little bit more work to do here. We have the y to the 2 minus 4, that's y to the negative 2. Here in the last term, I've got 1 over 2y cubed. That would be 2 cubed, which is 8, and y cubed. And then I think the last thing that I would have is just to simplify that second term. So this, when I multiply, when I have y to the negative 2 to the power of 3, that would be multiplying those exponents together. Y to the negative 6, and y to the negative 6 is the same thing as 1 over y to the positive 6. In general, and I mentioned this here, but in general, when we're writing out our answers, we'd like to write them with positive exponents only, if possible. And so here, this is what I would give as my final answer. There's not really much else that I could do. If I really felt like it, I could take these two terms, make a common denominator, and then combine them together. I don't really see if that's super helpful here, so this is where I'll stop with this one. All right, let's do a little bit more. Just to first rewrite this, I'm going to take that x to the negative 3 and rewrite this as 1 over x to the positive 3. And same thing with that second term, that y to the negative 1 on the top. I'll move that y down to the bottom and make it y to the positive 1. Now this one, since it's only two terms, I could really easily combine this to just make one fraction. I can see that we've got x's already in both. I have x cubed in the first term and x squared in the second. So this second term, I'm going to need to multiply that one top and bottom by x. The second term has a y in the denominator and the first one doesn't, so I'll need to multiply this one top and bottom by y. So I'll have y over x cubed y, and I'll have x over x cubed y, so y plus x over x cubed times y. And there's no other simplification that I can really do. Again, you won't be able to do any canceling here, and the reason you won't be able to do any canceling is if you thought about canceling a y would need to come out of all of the terms in the numerator. If you thought about trying to cancel an x would have to come out of all of the terms in the numerator. And unfortunately, the only thing that can come out of the numerator is 1 as a common factor. So, sorry, there's no other work that can be done. This is in simplest terms. Now, as far as what does a rational exponent mean, the connection between roots and exponents is that if you're talking about a root, that can be expressed as a fractional power. The nth root is the same thing as raising something to the power of 1 over n. And if we're talking about a power that's not just 1 over something, a power that's m over n, if that fraction's in simplest terms, then what we're talking about is taking an nth root and raising something to an mth power. And you can do that in whichever order you enjoy first. So you can either raise to the power of m and then take root of n, or take the root first and then do the power afterwards. Something that's sort of a constant throughout, of course, is that we use brackets to help shape things for us and give meaning. So if we're thinking about powers are only affecting the things that they touch, and if we want it to affect more than one thing, that we'll need to use brackets to make that happen. And this also includes things like negatives. So, for example, to compare and contrast negative 4 to the half versus negative 4 to the half, the first one, there is no bracket. So here, the power is only attached to the 4, not attached to the negative, which means that that's really root of 4 that's being made negative. And root of 4 is 2. 2, when you make it negative, it gives you negative 2. Similarly, if you have something like negative 4 in brackets to the half, this now, all of that is having the exponent of a half applied to it. So in which case, that is negative 4 inside the square root, and that's not a real number. We also have to be careful here about the usage of brackets, because something like this, something like xy to the half, it can easily be misinterpreted. But remember that if there are no brackets, that power is only, in that case, attached to the y. So for this, only y would be inside the root. However, if you had brackets around it, then the power of a half applies to everybody, so everybody is inside the root. All right, let's do a little bit of simplifying here. We have 4 to the 5 halves minus 27 to the 2 thirds. And so for the 4 to the 5 halves, that is the same thing as the halves is square root. The 5 is the power. For the 27, it's to the power of 2/3. The thirds, it's cube root. And the 2, that's the power. So we have root of 4 to the power of 5. That's root of 4 is 2. And if we were to take 2 to the power of 5, that's 2 times 2 times 2 times 2 times 2. That's 32. For 27 cube root, that's 3. And that's because 3 times 3 times 3 is 27. And 3 squared, that's 9. So 27 to the 2/3, that should be 9, taking cube root of 27 to get 3, and then squaring it to get 9. And then we just have to finish that off. 32 minus 9. There we go. That is 23. For the next one, I'm going to simplify this first by using the property of a negative power, meaning a reciprocal. So when I say 27 to the negative 4/3, that's the same thing as taking the reciprocal and having it to the power of positive 4/3. And the next thing that we know, of course, is that for a fraction, fractions raised to a power would be numerator to that power over the denominator to that power. So this would be 64 to the 4/3 over 27 to the 4/3. And that for both of them, we'll be taking the root, cube root, and then we'll raise it to the power of 4. 27, taking cube root, and then raising it to the power of 4. And now all that we need to do is just a little bit of quick calculations. Cube root of 64, that's 4, since 4 times 4 times 4 is 64. And if cube root of 64 is 4, then we'll have 4 to the power of 4 in the numerator, which is 256. In the denominator, cube root of 27 is 3, and 3 to the power of 4 is 81. So 256 over 81. All right, something like this. Again, I'm going to simplify inside of my brackets first before I deal with that power of a half. So inside my brackets, I've got 27 divided by 3, which is 9. I have x to the 6 divided by x to the negative 2. That's x to the 6 minus negative 2. I've got y to the negative 7 minus 1, because it's divided by y to the 1. I have z to the 2 minus 4. And all of that will be raised to the power of a half. Just going to clean up those exponents. 6 minus negative 2 is 8. Negative 1 minus, negative 7 minus 1, that's negative 8. 2 minus 4, that's negative 2. And now we've got a bunch of things multiplied together, all raised to the power of a half. So that means all of these individually are being raised to the power of a half. 9 to the half, x to the power of 8 to a half, y to the power of negative 8 to a half, z to the negative 2 raised to the power of a half. And then just a little bit of cleaning up. 9 to the power of a half, that's square root of 9, which is 3. For these next terms, we have powers raised to powers. You're going to multiply those exponents. 8 times a half is 4. Negative 8 times a half is negative 4. Negative 2 times a half, that's negative 1. And of course, we don't want to leave things with negative exponents lying around, so that y to the negative 4 and the z to the negative 1, I'm going to move those down to the denominator, y to the 4, z to the positive 1. There we go. And there, that's now in simplest terms. All right, last thing for us to do is a little bit of factoring. And for these ones, these are maybe a little bit more complicated looking because they have fractional exponents. But don't freak out. In fact, they are much the same as to how we would deal with any other sort of factoring. remember that if you were factoring something like 3x cubed plus 5x, you would take out the smallest power of x. So in this case, that would be the x to the power of 1 would be what you would take out. And remember that if you're trying to figure out what's left over, how we figure out what would be the power of x that's left over once we factored out x to the 1, you could figure that out by subtracting 3 minus 1, 1 minus 1, or in other words, 3x squared plus 5x to the 0, and x to the 0 is the same thing as just 1. Now, of course, we don't usually have to think about it that hard because when we're dealing with whole numbers, we've done enough work with it in the past that if you went and tried to take a common factor out of 3x cubed plus 5x, you would probably jump directly to that answer. You wouldn't have to think about, oh, we're subtracting exponents. You would say, oh, if you're factoring out x from x cubed, that would leave x squared. But if we're thinking about what's really going on underneath it all, we're subtracting exponents. Now, we're going to apply that same idea here, which is that when I'm going to be factoring, I'm going to take out the smallest power, and I'll figure out what's left over by subtracting. So in this case, if we're looking at what's in common for both, they both have y's involved, but I'll take out the smallest power of y, which would be the y to the negative 3/4. And that when I'm trying to figure out what's left behind, that would be done by subtracting. So the y to the negative 3/4 minus negative 3/4. Y to the 5/4 minus 3/4. Now for the first term, you probably don't really have to write that down because, of course, 16y to the negative 3/4, when you factor out y to the negative 3/4, the y is gone. You'll be left with just the 16. It's really more the second term that people struggle with, trying to figure out, well, what would be the power on the y for the second term? And remember that we do that by, again, subtracting the exponents. So we are subtracting negative 3/4. So I would have y to the negative 3/4 on the outside multiplied by 16 minus y to the 5/4 minus negative 3/4 turns out to be positive 8/4, which turns out to be positive 2. And now we're pretty much almost finished. The negative exponent can be made into a positive one just by moving things down below. And have we done all of the factoring that we can do? Nope, we have not. I can factor the numerator out as 4 minus y, 4 plus y. So that's kind of the key idea here, that for something like this to factor out y's to powers from these, we take out the smallest power, and to figure out what's left over, we use a little bit of subtraction. So we found out that y squared was left over when we took y to the 5/4 and we subtracted the negative 3/4 from it. That gave us y to the power of 8/4, which is the same thing as y to the power of 2. Okay, let's do another one here. We can see that here for both of these terms, I've got a first term and a second one. They both have x squared minus 3's to different powers, however. So I'm going to take out x squared minus 3, and I'll take out the one with the smallest power, which is the power of negative 1/2. So in the first term, that gets rid of the x squared minus 3 altogether. Only the x squared is left over. For the second term, I had x squared minus 3 to the 1/2, and I took out x minus 3 to the negative 1/2. So the power should be 1/2 minus negative 1/2. And of course, 1/2 minus negative 1/2 is the same thing as 1/2 plus 1/2, which is just 1. So really what we're left with is just x squared minus 3 to the 1. And now the only thing left to do to simplify this out is inside of this bracket, x squared minus 3, the x squares will cancel out. We'll subtract negative 3, that'll make positive 3. And that x squared minus 3 to the negative a half that I had here, I'll put it in the denominator as x squared minus 3 to the positive a half. And there we go. Let's do one more here. So here there's a mix of some factoring that can happen here. I can take out some common factors, easy ones. 3 and 12, they have things in common. X squared and x, they have things in common. And for the other for the other factors, x minus 3s to the 2/3 and to the 5/3, there's some things in common there. So we'll start with the 3 and the 12. I could factor 3 out of both. X squared and x, I could factor x out of both. And x minus 3 to the 2/2 and to the 2/3, and then the other one is to the 5/3. I'll take out the smaller power, which is the 1 to the 2/3. So let's see what's left over. In the first term, we have 3 was taken out, so the 3 is gone. From the x squared, we could take out an x, and that'll leave me with just x behind. The x minus 3 to the 2/3, I took all of that out, so all of that's gone. So first term, the only thing that would be left behind would just be x. For the second term, 12, factoring a 3 out would leave 4 behind. We had x, we factored x out, so that's gone. And then for the last one, the x minus 3 to the 5/3, what will be left over? X minus 3 to the 5/3 minus 2/3. So what do we have now? Well, I've got x minus 3 to the 5/3 minus 2/3, and that's the same thing as 3/3, which is the same thing as 1. So if you were to simplify what's inside of this bracket, we would have x, and we would have minus 4x, and we would have plus 12. So what we would have would be 12 minus 3x. So if you were to expand and simplify this, you would have 12 minus 3x. And now the only thing left that I could do as far as my one little extra move of factoring, and this is something that I don't think you have to necessarily do, you could take out another constant factor here of 3. 3 could come out of everybody, so that I would have, instead of 3 in the front, I would have 3 times 3, or 9. And 4 minus x left over. Again, I don't really think that's super necessary. I'd be happy if you stopped at that line. That's fine by me. But if you wanted to take out a constant common factor, you certainly can.